All right, so we just gave a brief introduction to power series. And definition 5 is not just a power series, but a power series centered at A. So this will look basically the exact same as what we had before. The only difference is that instead of an x to the n, I've got an x minus a to the n. And we say centered at A because anytime that you plug in an x value of a, all of these x minus a's are going to turn into 0. So it's like that's the spot where you're starting from. Instead of starting at 0, you're starting at a, and a counts as your 0. So these will look like your first term is still c0 because anything to the 0 power is going to be 1. And then you get x minus a to the 1 power, c sub 2 x minus a squared, c sub 3 x minus a cubed, and it continues on that way. So in particular, what we defined as a power series before just means a power series centered at 0. So the big question that we want to talk about with power series is when will they converge, when will they diverge? In particular, like we did up here, for what values of x is a particular series going to converge, and for which values of x will it diverge? And the typical thing that we use for this, the main, there are some like that one we saw above that we could use geometric, but usually what we use is the ratio test. So for what values of x does this particular power series converge? So remember, to do the ratio test, we want to do the n plus 1th term in the series divided by the nth term in the series and take the absolute value. And for the ratio test, we want to know when is that less than 1 and when is it greater than 1. So what is our a sub n plus 1? Well, it's this thing right here, except everywhere that I see an n, I'm going to put an n plus 1. And this will be a square root of n plus 1. And then I would divide that by a sub n, but instead I'm going to multiply by the reciprocal, just like we saw with the ratio test. I can do that. So that'll be a square root of n and an x plus 3 to the n. And this is all absolute valued. And what happens? Well, I'm going to rearrange here. I'm going to get my x plus 3's to the same spot. So these two things I'll get together, and that'll end up giving me an x plus 3 to the n plus 1 divided by an x plus 3 to the n. And then I'm going to multiply that by a separate absolute value, and here I'll put these two, and that'll end up being the square root of n over n plus 1. And we already sort of know some things about these. I can simplify relatively easily. In particular, this n is going to cancel with that n. I'm going to be left with the absolute value of x plus 3. And I really want to look at, if you remember, the limit as n goes to infinity of this thing. So I forgot to put that in here, but I'll put it in now. Limit as n goes to infinity. And the limit as n goes to infinity of the square root of n over n plus 1. The n and the n plus 1 are just going to get closer and closer together. They're always going to be 1 apart, but as you go to infinity, this whole thing is just going to get closer and closer to the square root of 1, which is just 1, so it's going to disappear. So what I end up with is that limit is just equal to the absolute value of x plus 3. So it converges if the absolute value of x plus 3 is less than 1, and it diverges if the absolute value of x plus 3 is greater than 1. And there's a nice way to rewrite this. This expression right here, the absolute value of x plus 3 is less than 1. I can rewrite it as -1 is less than x plus 3 is less than +1. And the reason is because absolute value of x plus 3 is less than 1 means that the x plus 3 has to either be bigger than -1 or less than +1, because it's only in those sort of fractional decimal ranges that when I take the absolute value, I'm going to get less than 1. And I can subtract 3 from all terms, and that tells me that my x is going to have to be between -4 and -2. And if I do the exact same thing but with the inequalities flipped, I'll end up getting that it diverges when x is greater than -4, or sorry, x is less than -4. And when x is greater than -2. Now there's one last question though. What happens when x equals -4 or when x equals -2? And there's a term for this. We need to check the endpoints. So let's do that. I don't know if I have room in this box, but I'll do at least one of them. What happens when x equals -4? Well, if x equals -4, I go back and I plug this into my original expression, and I end up getting the sum to infinity, n equals 0, of -1 to the n divided by the square root of n. And this is going to, it's an alternating series, and it is decreasing because my 1 over square root of n is going to get smaller and smaller as n goes to infinity. So this will in fact converge. Dang it. And what happens at -2? Maybe I'll do that over here on the other side. If x equals -2, we get the sum to infinity, n equals 0. -2 plus 3 would give me a +1 to the n power is just 1 over the square root of n. And this is a p-series. So it's 1 over n to the 1/2. So that's a p-series, but my p is less than 1, so this is going to diverge. P-series with p equal to 1/2, which is less than 1. So this means that, in fact, my final answer, it will converge if x is greater than or equal to -4, and it will diverge, and will diverge if x is equal to -2 or bigger. And actually, all I asked for was where it converges, so I didn't actually need this whole thing about diverge. I mean, it's still correct, but that is my interval of convergence, the term that we'll learn later. Okay, go ahead and pause the video now and try to do exercise 7 on your own. Okay, so exercise 7 looks pretty dang nasty. But we can do it. I believe in us. And really, if you're doing the ratio test, a lot of these things are just going to end up not really mattering much. So let's go ahead and do the ratio test. We want to do our a sub n plus 1 over a sub n. In this case, that's going to be a -1 to the n plus 1, x to the 2 n plus 1 plus 1, divided by n plus 1 factorial divided by n plus 2 factorial, 2 raised to the 2 to the n plus 1 plus 1. And then, of course, I'm going to be dividing that by a sub n, but the same thing is multiplying by the reciprocal. So this is going to give me an n factorial, an n plus 1 factorial, a 2 raised to the 2n plus 1 divided by a negative 1 to the n and a x to the 2n plus 1. Now, I'm going to cancel out a whole bunch of stuff. In particular, these negative 1 to the n's and n plus 1, when I take the absolute value, they're just going to go away. I've got an n plus 1 factorial that's going to cancel from both of those. My n factorial, well, maybe I should just combine all these together now. So let's see, I'll get the x's together. This x to the 2n plus 1 plus 1, that's going to be x to the 2n plus 3 over x to the 2n plus 1. And I'm going to be multiplying that by, I've got an n factorial divided by a n plus 2 factorial. And then I've got a 2 to the 2n plus 1 divided by 2 to the 2n plus 3, because when I multiply out this 2 times n plus 1 plus 1, that'll give me 2 to the n plus 3. So this is all going to cancel out with what's on the bottom, except for 2 of those 2's. Because if I've got 2n plus 3, I've got 2 more 2's on the bottom. And similarly, this is going to cancel out with all that stuff on the top, except I'm going to end up with 2 x's, or an x squared. And then my n factorial, n plus 2 factorial is just n factorial times n plus 1 times n plus 2. And the n factorials will cancel. So I end up with the absolute value of x squared divided by n plus 1 times n plus 2 times 4. And remember, what I really want is the limit as n goes to infinity of this thing right here. And the thing to remember here is that my x is a constant in the limit. This limit is really just looking at what happens as n goes to infinity. If I choose a particular value for x, suppose x is 100, I'm going to have 10,000, that's 100 squared. But as n goes to infinity, these two things on the bottom are going to go to infinity and get huge. So this is always going to equal some number divided by infinity, which is just going to equal 0. And that'll be true for all x, whether x is a huge positive number, a huge negative number, or whatever. So this power series we saw here converges for all values of x.